All right. Graphing square root and cube root functions. So square roots and cube roots, remember, are inverse functions of like y equals x squared. And so the y equals x squared, remember, that's a parabola. And so y equals the square root of x is the inverse function. So we're going to have a graph that is reflected over this diagonal, the y equals x diagonal. So it's like a sideways parabola, but in order to make sure that it's a function, we're only going to be graphing anything from here. So it's going to look kind of like just one side of the parabola, either the top or the bottom, depending on our a value out front. So the first one we have here is the parent function. Now, the general form of a square root function is going to be, you have your a, your leading coefficient, that tells you if it's above the x-axis or reflected below. So kind of like open up, open down, but it's more like, is it this piece or the below piece? Then we have x minus h, and then you have your plus k, where hk is kind of your shift. Now, y equals the square root of x is just our parent function. So if we're going to graph a square root function, I'm just going to use a table to do so. I'm just going to pick values for x, plug them in, and solve for y. So I'm going to pick values for x that are perfect squares so that I get no decimals. So I might start by the lowest number I can pick is 0. And I'd start with that. You can't square root any negative numbers. So the lowest one is 0. The square root of 0 is 0. Then maybe I'd pick 4, because the square root of 4 is 2. So I'm doing the square root of 4 to get 2 here. Then maybe 9. The square root of 9 is 3. And then that should be enough. So then I can graph that I have 0, 0, 4, 2, and 9, 3. And then it's going to continue infinitely in that same pattern. So you kind of see that parabolic shape, but it's only one piece of it because it's only defined where x is greater than or equal to 0, since we can't have any negative numbers under the square root. So the domain, remember, those are your input values. We can only have x's that are greater than or equal to 0. So if we plug in x's that are greater than or equal to 0 for this particular one, all our y values that come out will either be greater than or equal to 0 as well. So that's domain and range for this one. Now, if we start adding in a values, a value is going to change the kind of like the steepness, the amount, how quickly it rises up or down. And then it also reflects it over the x-axis. So if you have a negative out front, it would open down here instead. And then the HK moves it left and right, just like a typical shift. So we'll see some of those examples here. This is the cubed root function. This is the parent function. Cubed root is going to be similar, a x minus h plus k. So here, just the standard cubed root. So if you're going to do a xy table for perfect cubes, think, what could you choose for cubes? I would do 0 for sure. Now, you can cube root negative numbers. So y equals x cubed is the original. The inverse is the cubed root. So remember that y equals x cubed, that looks like the little s guy. So the cubed root, the inverse, is going to kind of look something like this, a sideways version of that, vertical. So you can have cubed root of negative numbers. So if you cubed root 0, you get 0. The next perfect cubed is 1. The cubed root of 1 is 1. And then the next one is 8. The cubed root of 8 is 2. And you can also do the reverse. The cubed root of negative 1 is negative 1. The cubed root of negative 8 is negative 2. So these numbers here are going to be the same every time for any time you do a cubed root function. So you're going to plug in the same, you're going to use the same table. Then graph those. So negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. So you can see that cubed root shape, but it's the inverse of the cubed root function. So it has been reflected over the line y equals x. Just like y equals x cubed, the domain is all real numbers because you can plug in the negatives here. X is an element of the real numbers for domain as well in the cubed root function. And although it looks like this will, it's not rising very fast here, it will continue to get larger. So the range is all real numbers as well. The bigger number you put in, the bigger number you're going to output. It's going to continue infinitely and approach infinity in both directions there. So how do we obtain the graph of y equals cubed root of x minus 2 plus 1 from the parent function, cubed root of x? That's where we got to look at this general form here, a cubed root x minus h plus k. So in our graph here, the cubed root of x minus 2 plus 1, our a value is 1, which means that there's no reflection, no vertical stretch. It's going to be the same shape like this. And our hk, though, is 2, positive 1. Notice that it's x minus h, so the h will be opposite. It's plus k, so the k stays the same. So our hk will be 2, 1. We're going to use this as our new origin point. So we're just going to take this graph and shift it all to the right 2 and up 1. So we're going to have a point right there. If I shift the whole graph, now I can just graph the cubed root of x, and I can do that by using my 5 points I did in the last one. The negative 8, negative 1, 0, 1, 8. Cubed root of negative 8 is negative 2, negative 1, 0, 1, 2. Then from this shifted point 2, 1, I can go to the left 8, and up 2, or down 2, I mean. So the point is actually negative 6, negative 1 is the point that's the real point, but from my shift, that's the one I want. So then to the left of there and down 1, and then 0, 0 is actually that point 2, 1. So I go through that point. Then from my shift point, my new origin, up 1 over 1, and then over 8, up 2. So I'm taking this graph, and since the a value didn't change, it looks the same as the parent function one, same shape, but it's been moved to the right 2 and up 1. The whole graph has been moved. So that's how we can use the parent function to make it easier to graph this. Otherwise, you would have to pick an x minus 2 from it, cube root that, then add 1 to it using this without the parent function. And there's a lot of room for mistakes there then. Here's another example. So this time we have an a value that is negative 2. That tells me it's going to be vertically stretched, which means it's going to look like skinnier because it's going to rise faster here. So it's going to look skinnier this direction. Or maybe it's going to look more wide that direction. It's been stretched, vertically stretched, the bigger value there. And since it's negative, it's been reflected over the x-axis. So how you're going to do this is you're going to get your HK still and shift your whole graph right and left first. So my H here is going to be 3, opposite of the H, same as the K. So 3, 2. I'm going to shift the whole graph over 3 and up 2, and I'm going to use that as my new origin point. And then I'm going to use my table, but this time since I have an A, I need an AY column. So this cubed root, so I'm going to pick negative 8, negative 2, or not negative 2, negative 8, negative 1, 0, 1, 8. And then the cubed roots of those are -2, -1, 0, 1, 2. And then similar when we graph parabolas, we have an a value, that's your last column. Our a value is -2. So multiplying everything in the middle column times -2 to get our ay column. So that's going to give me -2 times 2 is 4, -1 times -2 is 2, 0 times -2 is 0, 1 times -2, -2, 2 times -2, -4. And then, as we've done in the past with parent function graphs, we graph the first and last column then. And then we graph it from our new origin point. So this is our 0, 0s now, the HK. So -8 from our shifted point and up 4. -1 up 2. 0, 0 is that HK point, over 1 down 2, and over 8 down 4. So this is my new graph. So it's been shifted, it's been reflected, it no longer looks like this, it's been vertically stretched, it almost looks wider, and it's been reflected over the x-axis. So those are all the things that have happened to it since we've changed the a and we've added the shifted point. Okay, this is a square root function. So go back to our original square root of x minus h plus k. This is going to work very similarly. Start with your hk point, which in this one would be -3, 5. And you're going to shift the whole graph. So you're going to shift the xy axis to the left 3 and up 5. So this will be your new 0, 0, that -3, 5. And then the table this time, since it's a square root, we need to pick the square root ones like 0, 1, and 4, because you have the square root of x in the middle. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, you could do 9, square root of 9 is 3. Then we do have an a. Our a is -2 again, so we have -2 times y. So -2 times 0 in the middle here is 0, times -2 here, times -2, times -2. And then graph the first and last column. So our graph has been shifted to the left 3 and up 5. Our square root graph that typically looks like this, it's been shifted to the left 3 and up 5. It's also been vertically stretched, and it has been reflected over the x-axis. So it's going to end up looking like this instead in pink here. So we'll start with the 0, 0, and then to the right 1, down 2, to the right 4, down 4, and then over 9, down 6. And so you can see the vertical stretch and the reflection here. It's going to look like that. Now I didn't do no domain and range on the cube root functions because those are all real numbers, both of them. The domain, you can plug in any real number and you're going to get any real number out. But the domain for square root functions is a little trickier. So we can see on our graph here, all of our x values are greater than or equal to -3. So our range is all real numbers where x is greater than or equal to -3, because that's our cutoff point right here. Is -3 is the lowest one. If we look back up to our function, if we plugged in anything bigger than or anything smaller than -3, you'd get a negative under the square root. So that's why our x has to be -3 or more. And then if we look at our range, all of our y values are, it's all real numbers except for that all of our y values are below 5, less than or equal to 5. That comes from our k value, so our range corresponds to our k value. And since it has a -a, it's opening downward, and that's why all the range outputs are below that 5 then. So it's going to be equal to 5, that's the biggest output we're going to get, and then everything will be below. So I hadn't written domain over here is all real numbers and range is all real numbers. But for the square root, we have to be a little bit more careful because there's restrictions with square roots. You can't have negatives under them. Let's see what else we got. Wondering if I made the table correctly when I did this one. Oh yeah, I did 0, 4, 9. I missed 1, but that's okay. Okay, one more example. So, square root, find HK first. So this one would be -4, -1. Use that to shift your whole graph. Then you shift the whole graph to the left 4. That was terrible here. To the left 4 and down 1. Square root, so we're going to choose the same values for square root. Let's just do 0, 1, 4. So 0, the square root of 1 is 1, square root of 4 is 2. And then this time a is 2, so multiply everything in the middle by 2. So you get 0, 2, 4. Graph the first and the last column. Again, it's been vertically stretched. If it's a fraction out front, it's going to be a vertical shrink, so it's going to be skinnier. This one's stretched, so it's going to be a little bit more wide. It hasn't been reflected, so it's going to open up direction. So 0, 0 is at our shift point. To the right 1, up 2. To the right 4, up 4. And there we go. Domain is going to be all real numbers except for that x has to be greater than or equal to -4 this time. 2 reasons. One, right here is where our graph begins at -4. And if you look back at your original, you have to have a number bigger than 0 under your square root. So if you choose for -5, for example, you'd get a -1 under the square root, and that's undefined in the real number realm. So all real numbers except for you have to make sure all your x's are greater than or equal to 4. For the range, it's all real numbers except for y is greater than or equal to. This corresponds to our k value. Our k is that -1. And notice that it opens up. That's why it's greater than or equal to. So it's greater than or equal to -1 for our range. Okay, recap here quick. So remember that the h value shifts it left and right. Shifts your whole graph. K value shifts up and down. Use HK as your new origin, 0, 0 point. If A out front is greater than 1, it's going to be a vertical stretch. So it's actually going to look wider. If A is less than 1 but greater than 0, of course, it's going to be a vertical shrink, which means it's going to look more kind of like narrow. And if you have a -A, it's reflected over the x-axis. If you have a square root function, just stick to the same points every time. Choose 0, 1, 4 for square root, because the square root of 0 is 0, square root of 1, and square root of 4. Use those for square root. If you have cubed root, then use the 6 points that I gave you, starting with -8, -1, 0, 1, 8. Use those are 5 points, I guess. Use those 5, because then you'll always get the first 2 columns here will be the same. So if you have square root, use 0, 1, 4, 0, 1, 2. If you have cubed root, use -8 to 8, -2 to 2 for the first 2 columns. And then just change your last column based on what your A is. All right.